All right, we're back. We are still on page 65, and what we're about to do is mess around with this f of x here that we see. So the first thing that the problem says to do is see what f of x equals blah simplifies to according to your TI Inspire test. So I'm going to do that. Jot down the answer your calculator gives you and store it as g of x. All right, so let's do that. So switch over to the calculator and see what we can do. I feel like I have this stored somewhere, but I'm not really sure. Not here. Not here. Maybe I have more there we go. Sine of the tan inverse of the secant of the sine inverse of the cosine of the tan inverse of the secant of the sine inverse. Yes. Okay. I have it stored. That's great. So I'm not going to type it in again. You got to type it in if you don't have it. When you go to the calculator page, and so that's stored in F1. So I'm just going to say, what's F1 of x? F1 of x is this crazy thing. All right, so I'm supposed to store that as g of x. Is that answer? All right, done. Let me also write this down in the notes. And so bear with me, but also do it on your own while this is happening. So g of x is the square root. This is hard to write. Square root of -1 over x squared minus 3. Divided by the square root of, it's not fitting, but minus 2, which is like a really weird way to write that, right? So based on the simplification, what is the domain of the function above? So I'm just going to ask domain of g of x, comma x, which I've got like every time last time. So based on the simplification, the domain would be -√2 to √2. Okay, so here's the thing. When we asked what f1 of x was, it gave us an answer, but it also gave us this, and I'm going to click on that. Domain of the result might be larger than the domain of the input. So that's interesting. Like I found the domain of the result, and the domain of the result was -√2 to √2. I'm going to ask the calculator what it thinks the domain of f1 is. Right? So F1 is the non-simplified version. Domain of F1 of that. And what's weird is you can't really get the calculator to tell you what the non-simplified version is. It will always simplify it and then tell you that there might be a problem. So this domain is -1 to 1 exclusive. This domain is smaller than the domain that g of x has. So let's see if we can work out why. And it's with great regret that I do not have a class here, because usually I just have a student go to the board and do this, because this is a doozy. All right, so what I'm going to do is I'm going to simplify this and see if I can figure out where that domain is coming from. So -1 to 1, right? So same deal as always. I'm just going to start with this, combine these two, and then go from there, right? So start with a triangle. It all started with a triangle. It's like a weird children's story. And the triangle became a stupid line. All right, so sine is x. So x1 radical 1 minus x squared. That's like theta 1. So I need to find secant. So secant is 1 over cosine. Cosine is radical 1 minus x squared over 1. So secant is 1 over radical 1 minus x squared. So right now, I'm going to be doing the sine of the tan inverse. I should just copy this. Can I do that? Hold on, everybody. This could be a pseudo game changer, sort of. I'm going to accidentally get that. All right, hold on. Duplicate. Yeah, I'll erase the extra stuff there. And then let me get rid of you and you, because those combine to give me just 1 over radical 1 minus x squared, right? And then how many closing parentheses did I lose? I should lose the one for arcsine and the one for secant. So I should lose 2 of them. So let me duplicate all but 2 and throw those in. All right, this is going pretty well. Now, there is a thing though, right? Because look at this. Once we get this right here, x can't be outside of -1 to 1, right? Our domain at most at this point is going to be -1 to, well, you can't even include it, -1 to 1. So that's where the problem is, right? When you do the composition, you immediately reduce the domain to -1 to 1. It can never get bigger, right? So you can only ever get smaller as the domain goes. So based on that first composition, x has to be between -1 and 1. That's it. You can never get bigger. So let's keep going and see what we can do. So here we're going to do this, because there's a really interesting thing that's going to happen at the end of this. So let me, I wish I had done the first triangle in the right color. I'm so tempted to go back. I'm not going to though. All right, so tangent is 1 radical 1 minus x squared. Then what on earth is the missing thing? So it's going to be the square root of the first thing squared is 1 minus x squared plus 1 squared. So you get 2 minus x squared. And that's like theta 2. So I want cosine. So let's copy and paste again. So I want cosine, keeping this. And now I need to find in this triangle cosine of theta 2, which is not pleasant. Radical 1 minus x squared over radical 2 minus x squared. So this is not going to change our domain because domains can't get bigger, right? And radical 2 minus x squared is -√2 to √2, but we're already stuck between -1 and 1. So we're still fine. So I lost 2 more of these closing parentheses. So let's put this here, and we're going to go again. So we're going to deal with this part. So new triangle time, new inverse trig function, new triangle. So our new triangle is going to be for theta sub 3, I guess, and sine is the radical 1 minus x squared over radical 2 minus x squared. So this triangle is related to the last triangle. They have the same legs, so I know that this will be 1. And now I'm trying to find secant. So secant is 1 over cosine. Cosine is 1 over radical 2 minus x squared. So secant is just radical 2 minus x squared. So that's actually pretty nice. Let me copy and paste a little bit again. This is saving me like ages. Probably you're saying like, I can't keep up, but like, you know, work harder. I don't know. That's not really, I'm not seriously saying that. It's not fair that I can copy and paste and you can't. Unless you are also working on an iPad, in which case you can copy and paste, in which case keep up. All right, and then we got one more thing. I'm gonna use, I'm out of like the nice colors that I really like, so I'm gonna use this color, which I am not a huge fan of, but new triangle. So at no point have we made the domain smaller, right? It got to -1 to 1 on literally the first step, and it can never get bigger than that. And so it hasn't gotten smaller, so it's just kind of stayed what it was. So here, tangent, radical 2 minus x squared there. So then the missing side here is going to be 1 squared is 1, 2 minus x squared is, radical 2 minus x squared is 2 minus x squared. So 1 plus 2 minus x squared is 3 minus x squared. I don't know. So we're finding sine. So my final answer is looking sort of like the square root of 2 minus x squared over the square root of 3 minus x squared, comma, -1 to 1. That's what I'm getting for f of x. Now, that, if you remember, is not what the calculator got at all. The calculator had this. So this was the calculator answer. So let me just bring that down. So this was the calculator version. And the calculator version is a little bit weird. So I can show that these are equivalent. So let's let's do that. Let's like actually like go through the process and try to show that these are equivalent. So what I'm going to do is I'm going to say for this, this first radical right here, I'm going to distribute the negative into the denominator. So I get 1 over radical 3 minus x squared, right? Just distribute the negative in there. And then do the same thing for the second one. You get 1 over 2 minus x squared. And then since they're both radicals, we can put them all under the same radical. That's like a property of exponents. 3 minus x squared over 1, 2 minus x squared. And then we have some complex fractions. So really this is 2 minus x squared over 3 minus x squared. But then we have, we can reverse that property and say this is radical 2 minus x squared over. I am confident there's like some domain issues going on here somewhere, but you can see that they're equivalent, right? Like this is what we got by hand. This is what we turned the calculator answer into. Definitely equivalent. It's a wild ride though when you're doing these problems. So I mean, I enjoy doing them, but the warning that the calculator gave you about the domain turned out to really matter. Like that warning you needed, because the calculator initially simplifies to this, tells you the domain is this, but when you do the domain of the original function, this, you actually get this. And the calculator knew that it might be doing something dicey. That's why it gives you the warning. So when we did it, we picked up that domain immediately on the first step because we were trying to divide and we have this radical thing. Like you couldn't go bigger than 1, you couldn't go less than -1, picked it up right there. So you got to really, really watch out with compositions. I mean, they're not this complicated in general. This is like a very complicated problem just to demonstrate it. But anyway, I'm gonna cut this here. I think we answered every question in here. We really thought about it, looked through it. We simplified it by hand, which is crazy. So I'll be back in the next video to work on the next page, and I hope to see you there.